Hi, welcome back to Mthpt-103, and we're going to finish up the chapter with scientific and engineering notation. So hopefully you watched the video ahead about why we have scientific notation and then read the excerpt about why we use engineering notation. And so we're going to go through how to make those happen. So the first numbers that you see listed on this paper are just some examples of why we use scientific notation, right? If you wanted to write out the speed of light, you'd have to write 8 zeros. Not really excited about that. The other one that makes me not very excited is the mass of the Earth. It's 10 to the 24th. That's a pretty long number. It has 25 digits in it, so not really excited about writing that out. So to move to scientific notation, it has to have a number that is between 1 and 10 be in front of the decimal, and everything else behind that is how many you moved. So this first number, 356, when I think about this, I think about, is the number bigger than 0 or less than 0? 356 is larger than 0, which means it has a positive exponent. Whole numbers have the decimal behind at the very end on the right. So grabbing my pen, the decimal is behind the 6. So we're going to move it all the way until there's only a single digit in front of the decimal. So it's going to be 3.56. It was a number larger than 0, so it's a positive exponent. And I move the decimal 2 places, so it's 10 to the second. So that's scientific notation. Now you're like, why did I bother with that? You're right. A number like 356 is not a big deal. You can leave it. We're just practicing with it. Next one, 0.00825. So now this time it's a number less than 0, so our exponent's going to be negative. We're going to move it all the way so there's only a single digit in front that's non-zero. So 1, 2, 3. So it's 8.25 times 10. Now remember, it was less than 0, so it's a negative exponent, and we moved it 1, 2, 3 positions. 640,000. Decimals are at the very end. We're going to move it so there's a single digit in front. It's a non-zero. So it's 6.4 times 10. The number was bigger than 0, so it's a positive exponent. We moved it 1, 2, 3, 4, 5, so it's a positive 5. Number smaller than 0, 1, 2, 3, 4, 5, 6. So it's 4.5 times 10, less than 0, so it's negative. 1, 2, 3, 4, 5, 6, negative 6. So that's how we switch into scientific notation. Now let's do the other way and switch out. So these are written in scientific notation. The number 3 has a decimal right behind it on the right-hand side. Since the 8 is a positive, this number actually is a larger number. So I have to think, okay, I need to make the number 3 grow. In order to make the number 3 grow, I'm going to move the decimal to the right. So I'll show that. Here's the decimal. I need to move it to the right 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. Now I have all these spaces, so I think, okay, what can I put there that doesn't change its value? If I fill it with zeros, the value won't get changed. So I'm going to put all these zeros in here. So if I write it nicer, 1, 2, 3, 4, 5, 6, 7, 8, put some commas in. My 3 times 10 to the 8th is actually 300 million. Okay, number 2, we have a positive exponent, so that means we need to make our number grow, so we're going to move our decimal to the right. Now, the difference between number 2 and number 1 is there weren't any numbers behind the decimal in number 1, but in number 2 there is. So you have to count those when you count your positions that you're moving. So it's right here between the 5 and the 9. So I'm going to start counting. 1, 2, 3, 4. So I've already used 4 of the positions. 5, 6, 7, 8, 9, 10. I only have 6 blanks where there's no numbers. So if I go ahead and write that number, I'm going to bring it over here since it's getting a little crowded. 5, 9, 7, 4, 2, 1, 2, 3, 4, 5, 6. So hundredths, thousandths, millionths, so it's 59,742,000,000. So that's definitely shorter if we write it in its other form. Now this is a negative exponent, so since it's negative, I actually have to make the 2.3 get smaller. In order for it to get smaller, I have to move the decimal to the left. So the 2 is going to count as one move. Now I have to make 3 more. 1, 2, 3. I have 3 empty spots. Those are going to get filled with zeros. You can put a 0 in front of the decimal or not. That's your personal preference. I had 1, 2, 3, 1, 2, 3 empties, and then I have to follow that with the 2 and the 3 because I don't want to lose any of the numbers. The next one, it's a negative 11. So we're going to go ahead, it's negative, so it's a small number. I have to make this smaller, so I'll do that by moving it to the left. 1, so I've used 1 of the 11, so I need 10 more. 2, 3, 4, 5, 6, 7, 8, 9, 10. If I look at how many blanks I have 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I followed up with the numbers that were there. So this is another example of such a small number that it was much easier to write it in scientific notation. Now, just like we can manipulate regular numbers in decimal form, we can manipulate scientific notation. To do that, you put together like terms, and we're going to use our rules for exponents. So this first one, 4 times 10 to the negative 6 times 6 times 10 to the negative 10. The 4 and the 6 are our decimal form. We're going to multiply those. So I get 4 times 6, which is 24. Now we're going to put together our 10 to the negative 6 and 10 to the negative 10. So remember what we do with bases. We take their exponents and we add their exponents when we are multiplying. So I'm going to add negative 6 and negative 10. I end up with 24 times 10 to the negative 16. Now, when you have a problem, if your beginning numbers were in scientific notation, your ending answer should also be in scientific notation. So we need to change it up. So 24, the decimal is after the 4 on the right-hand side. I need to move it 1 to the left. 24 was a number bigger than 0, so I'm going to add, because that would be a positive exponent. I'm only moving it 1, so just a plus 1. So it becomes 2.4 times 10 to the negative 15. So my final answer is in scientific notation because my original number was in scientific notation. Okay, number 2 is dividing. So we're going to go ahead and divide the numbers that are in decimal form. 4.5 divided by 1.5, that's 3. Now we're going to divide the base 10s. So if you think about what we do when we're dividing, we subtract the exponents, so it's negative 6 minus negative 8. 2 negatives become a positive or an addition. So it's 3 times 10, 16 plus 8 is 24. It's already in scientific notation because 3 is between 1 and 10, and then I'm good to go. Now 3 is actually putting together what we did in number 1 and number 2. We've got multiplication and division. So let's do the multiplication first and then we'll come back and do the division. So we're going to do 4 times 6 and get 24. We're going to take 10 to the negative 5 and 10 to the negative 3. Since I'm multiplying, I'm going to add exponents. So it's 24 times 10 to the negative 8. We're going to do the same on the bottom. So 3 times 8 is 24. Then we've got, oops, I should have put that over here. Negative 10 and positive 8, so negative 10. I'm multiplying, so I'm adding the positive 8. Negative 10 plus 8 is negative 2. Okay, now I don't have to switch it to the final scientific yet. Let's finish the division and then we can switch if need be. So we're going to take 24 divided by 24, which is 1. We're dividing, so we're going to do negative 8 minus negative 2. That again becomes a plus. So our final answer is 1 times 10, negative 8 plus 2, that is -6. Notice we didn't have to switch to scientific notation during the process. If our final answer wasn't in scientific notation, then we would have switched it. Okay, last one here for scientific notation. We're going to do a power. I can see all of this is to the third. Remember when we did rules of exponents, that means everything on the inside has to go to that power. So this third power goes both to the 1.2 and to the 10 to the 6th. So we have 1.2 to the third times 10. Now when we had something to a power, we multiplied exponents. So in my calculator, I'm going to do 1.2 times 10 to the, I'm going to do 1.2 to the third power. And I have 1.728. 6 times 3 is 18. This is already in scientific notation because I have a number in front of the decimal that's a 1. So I am good to go, and that's my final answer. If you have any questions, go ahead and email me. I'm going to start here, stop here, let you take a break, and then we'll come back and do the engineering notation.